In this video, we're going to talk about how to use the calculator, the Nspire CX or CX2, to find roots of really any polynomial, but specific to this video, quadratic. Okay, so just to kind of give some context to the problem that we'll be looking at. Here's the problem that we're going to generate a quadratic out of. Okay, so it says we've got consecutive terms of a geometric sequence, and the goal is to find k, right, in this sequence of consecutive terms. Okay, so if we have a geometric sequence, that means that the next term is generated by multiplying by a common ratio, which we call r. Another way of saying that is that if we divide two consecutive terms, that result will be the same number because that is the ratio. So for example, if I take this middle term 2k and I divide by k minus 1, that's shown here, that's going to equal the same thing as if I take 21 minus k and I divide by 2k, because again, to go from one term to the next, we're multiplying by r. So that means that if we divide one term by its previous term, we get that common ratio. Okay, so that's just a setup, but the point is that if you have these two ratios equal and we solve, we cross multiply, and we get this resulting quadratic. Okay, in this Nspire CX software, we're going to have to set that quadratic equal to 0. That's always a good habit to do anyway. This one factors, so we get as our answers 7 over 5 and 3, but let's just show how we would do that on the calculator. Okay, so if I go over to the Nspire face, the first thing I'm going to do to call up the solver is I'm going to push menu. I'm going to choose option 3, which is algebra, and I'm going to choose, instead of numerical solve or nsolve, we're going to choose polynomial tools and find roots. Okay, I'm just going to choose the general find roots. We have real and complex, but let's just choose the general one. Okay, degree, well, for any quadratic, that's degree 2. Like I said, you can use this to solve any polynomial, but we're specifically looking at a quadratic, and we just confirm that we want real roots. Choose OK, and it's going to prompt us, right? Here's the equation. It's got to be set equal to 0. Our variable is x here, so that's a little bit different because we have k here, but it's okay. We can just use the coefficients. So on the squared term, the coefficient is 5. On the term raised to the first degree, the coefficient is a negative 22. So I'm going to put those in before I forget. Okay. So for a2, I'm going to put, what was it, 5? And then I'll push the down arrow. Or you can also alternatively push tab, which is, it's embarrassing, I can't remember. Oh, it's over here. Okay. The A1 in this kind of layout is the coefficient of x. That was negative 22, and then our constant term is 21. So I'm going to put negative 22. I'll push tab again and put positive 21. Okay. And I just double check everything's right. I can click enter. This is the other thing you can do. If you like typing it in, the name of the command that you use is PolyRoots, and then the syntax is the equation, comma, x, and x is the variable that we're solving for. This equation has to be set equal to 0. All right, but if I just push enter now, you'll see we get 7 over 5 and 3, which matches what you get here. Okay, so I will make one more video, actually this same problem, but how to solve graphically, but that's a really good way to find the roots of any polynomial pretty quickly. Okay, and it will find them all, which is nice. All right, till the next video.